Now let's look at differentiation of a quotient of two functions. Now, in this case, when we talk about quotient, we mean when you have two functions dividing each other, how do you go about solving that or differentiating two functions that has to do with quotient? Now let y be equals to u over v. So here you have the numerator part standing for one function, u, and the denominator standing for another function, v. Now, if I'm to differentiate this, what do I do? The y, the x. Now recall, alphabetically, your u comes before your v. So this means you're going to differentiate the u first, so you keep the v constant and differentiate u, the u, the x. Because it's quotient, that means you're dividing, it takes the minus sign. Then at this point, you keep u constant and differentiate v in respect to x. Divide the denominator, v, by u squared. This is like the formula or guiding principle in differentiating a quotient of two functions. Now let's take an example. This is example 1. Let y be equal to sine x over x. So how do I differentiate these two functions? Follow the principle. The y, the x will be, keep the v constant. The v is the denominator, which is x. Differentiate sine x. Remember, if you differentiate sine x, the standard derivative, it is cos x. Minus, then keep sine x constant. And differentiate the v, which is the denominator, x. If you differentiate x, it's 1. So you can choose not to write it. Divide v squared, which is denominator. The denominator here is x, so x squared. This is the solution to the question. Let's try out number 2. Y. Let y be sine x over x squared. Now, if you have a function like this, what do? The same procedure. The y, the x will be, keep x squared constant, which is the denominator, and differentiate sine x, and that's cos x. Minus, then keep sine x constant, and differentiate the denominator, which is x squared. If you do that, it's going to be 2x. So 2x comes here so that your work will be organized. And then x squared. Remember, you have to square it. So since x squared is already there, then you square whatever is there. So this gives you x squared cos x minus 2x sine x 2 times 2, x raised to the power 4. Here, I can decide to factorize. If I do, highest common factor is x. Open the bracket, it becomes x cos x minus 2 sine x. Close bracket. And this is x raised to the power 4. You see here, one of the x can cancel. So if one of these x cancel one from here, final answer will be x cos x minus 2 sine x over x raised to the power 3. This is like from indices. For example, if you recall, this is x, this x, division means minus. So the power here is 1 minus the power here, it's 4. And that gives you x raised to the power minus 3. which is the same thing as the inverse x raised to power 3. So it means the x raised to power 3 will be at the denominator. That's why you have it this way. Now, number 3 example. Number 3 example is y. It's equal to sine x over cos x. So we are differentiating this. But before we do, we just want you to remember something in what we call trigonometrical identity. Trigonometrical identities. These are formulas you must remember which will aid you as you solve some questions. One of them is this: sine square x plus cos square x is equal to 1. Now it's important to remember this. Another trigonometrical identity to remember is that 1 over cos s is equal to sec x. And if this is true, it therefore means if I have 1 over cos square x, it is going to give me sec square x. So number 3 arises from number 2. If 1 over cos x is sec x, then 1 over cos square x will be sec square x. Then it's also important to know that sine x over cos x is equal to tan x. Now, these are the identities I want you to remember. We will need it when the time arises. So let's go back to the example number 3. I'm differentiating the function y equal to sine x all over cos x. Now, how do I solve this question? Now, for space, I'm going to start from here. The y dx will be, it's still the same procedure, keep cos x constant, then differentiate sine x, open a bracket for it. If you differentiate sine x, you get cos x. Then you close the bracket. Minus, this time around you keep sine constant, sine x, and differentiate cos x. If you differentiate cos x, it's minus sine x. Remember? Yeah. Then divide the denominator, which is cos x. Then you square it. If you do that, this becomes cos x times cos x is cos square x minus sine x times, because bracket means times minus sine x. This will give you plus sine square x. Now, what is cos x squared? It is cos square x. Now, we are done with the differentiation, but our working indicates that there's need for us to simplify further. We can't just leave our values like this, our expressions or our equations like this. So what do? Now remember from your trigonometrical identities, sine square x plus cos square x is equal to 1. So this means the entire numerator is 1 over cos square x. So here, this is your dy dx. This is also your dy dx. It's an equation, so it's a continuation solution. But again, we cannot leave our equation as 1 over cos square x. From trigonometrical identity, 1 over cos square x is sec square x. So the final value for this will be sec square x. That's all, we're done. So we can see that it is very easy. solve questions like this. All you need to remember are your trigonometrical identities. They can help you in finding solutions to this question. Now let's take example number 4. And this will be the last example for the quotient of two functions. Y is equal to 3 exponential function divide cos x. Now find the y dx. The y, the x will be keep cos x constant, then you differentiate 3 exponential x. That will still give you the 3 exponential x in bracket minus, then you keep 3 exponential x and differentiate cos x. If you differentiate cos x, it's going to give you minus sine x. Then the denominator, cos x all squared. Now, this will be 3 exponential function cos x minus times minus plus, and then 3 e raised by x times sine x will give you 3 e raised by x sine x. What is cos x all squared? Is cos square x. That's it. Now you can decide to take a step further, factorizing to get a final equation. Highest common factor here is 3 a raised by x. So this is cos x plus sine x over cos square x. So that is the solution to the question. Would you like to attempt some questions where you have 3 exercises to do? Differentiate the following: 1 cos x over x, 2 sin x over x cubed, and 3 2 e raised to power x over sine x. Now attempt this question, put your answer in the comment section.